So guys, today we are going to tackle exciting tree question, and in this question the question has asked us to convert a sorted array into binary search tree. And we also need to keep one thing in mind, that we have to produce a balanced binary search tree. You can see that from the example we have been given an array which is sorted one, and at last we need to output a binary search tree which is balanced. Let's see the logic behind it. So guys, to solve that problem, let's take a simple example, and for the example we are going to use this array. And as you know, to find the balanced binary search tree, we first need to place the middle value as the head of the node so that the left and right branches will be balanced out. Let's see with an example. As you know, to find the midpoint, we are going to find the midpoint with this formula: m equals to l plus r minus l by 2. Here l means left index and r means right index, and at initial phase our left index will be 0 and our right index will be 4. So our midpoint will be calculated at 0, which is second index, and we are going to construct a binary search tree head with that value of 0. And now, as we have completed and placed this value, we are no longer going to consider this, and we are going to recursively call this section and this section and find the midpoint of each and every section, and we are going to expand this tree. As the left value is 0 and our right index value is 1, our midpoint will be minus 10, and as minus 10 is in the left section of 0, we are going to create a tree node of that value. And we have completed constructing this, and the only element that is remaining is minus 3, and we are going to, as we are going recursively, it will be automatically placed in the right side of 10. As minus 3 is greater than minus 10, we are going to place it right in the right side of minus 10. And this section, this left section of 0, the midpoint is completed. Now the right section is remaining, and the midpoint of 3 and 4 is 5, this value. We are going to construct a branch out a right section of the head value with that value inside of it, 5 onto it. And we have completed this element. Now the only element that is remaining is 9, and we are going to place it in the right section of it. So we have constructed a balanced binary search tree with an sorted array, and you can see that as we have placed the center element at first, and we are recursively also finding the center element of right and left, we are making the tree balanced. So now let's see the code example for this. So guys, this is the solution, coded solution of that problem, and you can see that we are using the same example, and we are passing that variable inside this function, and we are doing the housekeeping at first and returning null if the datas are invalid, and we are calling this helper recursion and passing the left value as 0 and num's length minus 1. Its length minus 1 will be yielding us the right index initially, and passing also the array inside this recursion. And we have the base case: if the left value is greater than right, then we have completed that section of the tree and we are going to return null. If not, then we are going inside the recursion and we are finding the midpoint, which is the same formula that we discussed on the slide, and placing that value by creating a new tree node inside the node. And we are also traveling the left path by passing the left and mid minus 1, because we have used the value of mid index, that's why we no longer want it. And we are also traversing the right part of the recursion by passing mid plus 1 and right index, and at last we are returning this node, and this is also returning this in the main function. Hope it makes sense. You can get this code on the description section. I have linked a GitHub link. Thank you guys.